So in the Pac-Man game system, I decided the player would be one of the external actors and that the system would be the other external actor. The player, as shown in the use case diagram, can control whether the Pac-Man wants to eat a pellet, or it could run the Pac-Man into a ghost and get eaten by a ghost, navigate the Pac-Man through the maze, and turn the game off and on. And on the other side, the system's role or behavioral job is to make sure that all these things that the player does is accurately represented in the system and is accepted and actually shown back to the player. So these sort of things, if the pellet gets in by the player, then the system's job is to remove the pellet from the screen, which is remove pellet for eaten, and then add points to the score, and other sort of jobs like changing the level if all the pellets are eating, so change level and produce the game from the JSON file. I left a little bit of space in the middle to differentiate between the two sides and make it easier to read and understand. And additionally, the bubbles are in alphabetical order from top to bottom, so it's easy to look at it from multiple times over. You understand where everything is quite quickly. Moving on to the sequence diagram. I've got two participants in this diagram. So I've got the player on the left side and the game system on the right. In this scenario, player loses a game of Pac-Man. And as per the scenario, the player first starts the game, so it sends a message to the system through the message line, and I use this format for the message line between the two for the entire diagram. I added the loop here, see this box, to demonstrate step 7 of the scenario as mentioned in the assignment specifications. So if the player moves the Pac-Man through the maze and then the Pac-Man collisions with the ghost, that will be repeated for how many lives it has, and then outside the loop the game ends. So I also used execution specification boxes to highlight the focus of control within the system. So the player sends a message, and this little box here shows us the game system is taking up most of the control and focus of the system and processing what is being sent to it.
Moving on to the UNO diagram. So it's quite large.
Firstly, I organized all the classes to be close to other classes they associate or interact with in any way to avoid clutter and complexity within the diagram, such as putting the ghost and the Pac-Man together and right next to their abstract class entity, so all the arrows are quite close and there's no crossing lines. And also a similar thing as the JSON settings and level settings. For example, if that was up here, it would cross the entire diagram, so that was one of the first decisions, is the spacing. I also followed basic object-oriented theory when I made the entity abstract class, so that both the ghost and the Pac-Man could inherit the common attributes that they both shared, and I figured that out, and so they both had positions on the screen and the speed from the JSON file, as well as the move methods and the draw, because it has to be drawn onto the screen. The move operations use different. The move operations in the Ghost and Pac-Man are also different to suit their own behaviors, and this is a form of polymorphism. The solid principles were also considered when creating the diagram. By separating all the responsibilities of the system equally, each class has a single responsibility in the system. This was the main reason I created an entire new class for level settings instead of having it all in JSON. This design is also open for extension, but not modification, due to the abstract class entity. Finally, creating small classes with things such as position and map make things easier as they are used often, and I discovered that this makes it easier from previous experience in Java game creation.